So today we're just going to learn loops and methods at the same time. So we're kind of just going to review the stuff from lesson one in case you forgot. So yeah, the stuff we learned in lesson one was basically like the basics of Java. So that's stuff like printing to the console. So if you type like a command like system.out.print, if you type this line and you write in the parentheses what you want to be printed means it's going to be displayed into the console. Right, which is why hello world is here. So this is kind of important for when you want to just display stuff in the console and kind of mark out your code. That's normally when I use print statements, and also like labeling important numbers, things like that. So it doesn't seem important right now, but it's usually pretty used in programming. Okay, next. We also talked about making variables. So variables are like things that in Java that store values, right? So we can store numbers, so that's integers and decimal places, numbers with decimal places, also doubles. As a variable, we can also store stuff like Booleans, which are just true or false values, and strings. Strings meaning like words, sentences, characters, anything that you want to put as a string, you notify it, you kind of classify it with these quotation marks here. And remember, you also have semicolons. So the way you declare these types of variables, declare basically means making these variables. The way you do that is declaring the type. So you're just stating the type of value that you want to store. That can be like integer, double, Boolean, character, and string, which are the most common types that we use. And then put the name, an equal sign, which means you're assigning the value to the variable. And then the semicolon, value and semicolon. So we make variables all the time. Yeah, and they're pretty important too. So everything we learn in Java in the beginning, at least, is like crucial for understanding the rest. And then we also talked about conditionals. So conditionals are basically a statement that performs an action based on whether a condition is true or false. So the condition, for example, in English, it'll be the condition is it raining? If raining equals true, which means it is raining outside, then the action is to bring an umbrella, right? But if raining is false, then nothing happens. You don't want to bring an umbrella and you're just going to walk outside. So that's basically conditionals in English, and you can translate it into programming the same exact way, right? If the condition is true, the action will occur. If the condition is false, the action will not occur. And this is the structure, right? You can test for multiple conditions with else if statements, right? So if this condition here is true, then the code in red will be executed. If the condition is this condition up here is false, then condition 2 will be executed. And at condition 2, it's going to move on to condition 2, right? And if this is true, the pink code will be executed. But if it's false, it'll move to condition 3 and so on, right? If all of these conditions up here are false, then it'll just carry out whatever is in this else statement. So that was like a quick summary of conditionals. And the notion of using conditions to determine whether or not you want to complete an action is kind of carried over the same way that we talk when we talk about loops, right? So that's something important to remember. So loops are basically a series of instructions that are repeated until a condition is met, right? So instead of having to copy and paste a certain amount of code over and over again, you can just put it all within a loop and then tell the loop in the condition how many times you want the loop to run, right? So for instance, let's say you wanted to draw 100 circles on your paper, right? You would have to move your hand in circular motion 100 times until you've drawn all 100 circles, right? So the condition is to draw 100 circles, right? So if you haven't drawn 100 circles yet, that means the condition is true and it's going to keep going. But if you have drawn 100 or more circles, the condition is false and then the loop will stop, right? And this is the instruction. So this is basically like loops in English. It just repeats a series of instructions until a condition is false. So in Java, you can write these loops in 2 ways. So we're going to talk more than 2 ways, but the main ways are while loops and for loops, right? So a while loop is basically a loop where you declare the starting value in the front, like outside the loop. Then you have your condition in the parentheses here and your code that you want to be executed within these brackets here, this bracket and this bracket, right? So this is where you kind of start the loop, and this value kind of controls the loop. It controls the loop, how many times the loop will run, right? So if you say that I equals 1, right, then that's the starting value. And then your condition is that I must be less than 4. So if I is less than 4, then the code will execute. But if I is not less than 4, then the code will not execute, right? Because this condition here has to be true. So we can kind of just go through the loop and just think about it logically, right? So if 1 is less than 4, then it's going to print out 1 and then increment it, right? So 1 will be printed and then the value will increase by 1. So that's kind of changing the condition, the control of the loop, so that the loop doesn't keep on going on and on again, right? It moves on to the next stage of the loop, which is where I equals 2, right? And since 2 is less than 4, 2 will be printed. And then you will add to 2. So now 2 will become 3. So now I is 3. 3 is less than 4. 3 will be printed. And then now I is 4 after you increment it one more time. And 4 is less than 4, right? And that means this condition is now false because 4 is not less than 4. 4 is equal to 4. So this loop will stop. And then this will be the final output, right? You can kind of visualize it like this. So this is the starting value. Your condition is here. And you want the loop to carry out if your condition is true, but if your condition is false, then nothing will happen, right? So while your condition here is true, then it's gonna print I and then add 1 to I and then check this condition all over again, right? And as long as it's true, this whole like loop here will occur, right? But if it's false, that means I is not less than 4, the loop will end. So that's basically the gist of while loops. And this is how you write it, right? You want to declare your starting value up here or your control variable is up here. Your conditions in the parentheses, and then your code is within the brackets. So it's within the while loop, right? So here again is the structure. You want to declare your type. So type basically means like int. It's like declaring a variable, right? You're using a variable to control your loop. Okay, so we kind of introduced a word called increment that you probably might not have heard of. So by increment, we just mean that we're increasing the value of the variable, right? So in this case here, all these 3 cases, we're increasing the value by 1, the value of x by 1, right? And the reason why we increment or we change the value of a variable is to make sure that the loop doesn't infinitely run, right? Because if this line of code wasn't in here, then x will always be 1 and 1 will always be less than 5 and 1 will just be printed continuously, right? And that's not what you want. You want to keep going until the condition has been met. You always want the condition to be met. Yeah, in the end, right? So there's a few ways that you can add 1 to a variable. You can do it 3 different ways, which is you can see by these arrows. This is the shortest way, and it's usually the easiest just because it just takes 3 characters that you need to write, x plus plus, which basically means you're adding 1 to x, right? You can also do it this way, x plus equals 1, which I think we talked about last time. But it's also adding 1 to x. You can do it this way too, but this is normally faster. And then you can also do it this way, right? So all these 3 things mean the same exact thing. But important thing, you always need to change this control variable. By the end of your loop, it should be able to end. Okay. I guess we could just do this practice really quick. Yeah, I think we have time for practice because I was talking pretty fast. I guess Chloe, since you're the only person here, not to call you out. But yeah, do you want to put your answer in the chat? Or if you have any questions, because it's going over pretty quickly. I mean, Noah, yes, you can answer too if you would like. But I guess it's not very fun if you're just, you know all the answers already. It could be D. D is close. You also have to pay attention to where this X is, right, in relation to the entire loop, right? So if you kind of go through it from the beginning, right, we start at X equals 0, right? So you enter the loop, X is 0, and then you carry out this statement here first, right? So X is now 1, and then you print it. So it starts at 1. So you were close with D, right? But just be careful like where X is in relation to the entire loop, right? This answer here would kind of be more right if X were underneath here. It's like if it was X plus plus here, right? So then 0 would be printed first, and then you would have a space here, which I'm just gonna note it like that, and then you'd print 1, right? But instead X is at the top, right? Does that make sense? So X, you add 1 to X first, and then you print it. Okay, let me know if that doesn't make sense. We can just practice. We'll just do one of these. Yeah, I guess I'll give you a few minutes. Practice. Nice. Okay. Yeah, I'll give you a few minutes to write this while loop. If you need the notes, I have a copy, I think, if I can access. Yes. That you could just refer to here. So you should be able to go on that and just like look at the while loop format so that you could see how it's done. And then I'll go over it in a few minutes. Wow. While not, technically, not is not in Java. Not technically, but it actually isn't. Yeah, I think it's just Python. Well, I think it's just Java that doesn't allow this not, but Python does. You have to use like an exclamation mark or whatever. The inconvenience of Java. I think you can just put the exclamation mark in front. But technically it's supposed to be X not equals because it's X. There's no X in the condition. Well, not 60. Yeah. What we want to do is we want to print the while, you want to use a lot while loop to print all the multiples of 3 from 3 to 60 inclusive, right? So our starting value is 3. You can basically pull a lot of clues out of this one question. Our starting value is 3 and the ending value is 60. So we can just form a while loop. So the first thing we want to do is we want to write out the starting value. So we can just say int x equals 3, right? This is going to be our control variable. And then we want to say while x is less than or equal to 60, right? Because we want to print all the multiples from 3 to 60 inclusive, right? So while x is less than or equal to 60, we want our code to occur. And the out.print, just say x, right? Because because we want to print out all the multiples. Right, in order to get all the multiples, we would have to change our increment, right? Instead of incrementing by just 1, we can increment it by 3, right? And this gets us all the multiples of 3, right? Because if we go through the loop, x it starts with x is less than or equal to 60. So it's going to print 3, and then it's going to add 3 to 3. So that's going to be 6, which is also a multiple. 6 is less than or equal to 60, and it's going to keep going. Right, so if we run this, we can check it. It prints all the multiples. So the 3 things you pretty much change, or 4 things you change with your while loop, is your start variable or your control, your condition, the code to be executed, and then how you're going to change the control variable with each change of the loop. Okay. Here's a code here. You can also just do more of these as practice, but we're going to move on to next loop. Okay, for loop. So that was while loops that we just discussed, and now we're going to talk about for loops, which I think is a little more complicated just because like this part here normally just confuses a lot of people. But it's pretty much the same thing as a while loop. Sometimes it's used for different reasons, and sometimes it's better to use a for loop than a while loop, and vice versa. But it's kind of the same. So you have your start condition here, your starting variable here, which is basically like your control. It's the same thing as if we go back here. It's the same thing as this up here, your start. And then you have your condition, which is always going to be I is less than 6, right? So your condition's here, same thing as a while loop. And then your increment, right? Which is how you're going to change the control variable. So that's where your increment is here, right? And after you have all this written out, you're going to write your code to be executed in between the braces. Yeah, so it's basically the same thing. If I go to the slide, you can see how you can transfer while loops and for loops. A lot of time when you have this information here, you can just transfer it right into the for loop. So it makes, like, if you kind of compare the two, it makes it a little easier to understand, I think. You can kind of break it down. It's pretty much the same. You have like the blue up here and the blue here, the red here and red here, and then the purple here, and then the code to be executed within the braces. And it prints out the exact same output, right? So for loops are typically used when you know exactly how many times you want the loop to run, right? While loops, your condition can be a little different, right? But for loops is usually used because you can have it all written here and you can just count out exactly how many times you want the loop to run, right? But most of the time they can be used interchangeably. So I guess like the more you go into programming and the more you code, you kind of learn to differentiate the two. But like when you're learning, I kind of use them like interchangeably, and I kind of learned that it's better to use while loops during this type of situation than for loops during another type of situation. Okay. I guess I'll just go over this really quickly. Yeah. So to replace the missing code to print the for loop, to print this, you're basically going to follow the same structure as before, right? So the first part is your initialization, which is basically how your loop is going to start. So it's a starting variable, right? So you're going to start as int I equals 6, right? Because you have your starting number here, and that's all the information you need. And then you're going to put a semicolon, and you're going to work on the next part, right? So the next part is the condition, right? And you want this to print, and the last, you want it to print like a continuous series of instructions. And the last number that's printed is 16, right? So that basically is your end condition, right? So you're going to say like while I is less than 16 or less than or equal to 16, it goes like this. While I is less than or equal to 16, you want the loop to run. Because when I is 17 or up, then it's not going to print. And the condition will be false, right? So this here is your condition. And then you're going to increment, right? So you're going to add 2 to I, right? Because the difference between 6 and 8 is 2, and it goes by 2 each number. So that's pretty much your condition, right? That's exactly what goes in here. You have your initialization, your condition, and your incrementation. Incrementation. Yeah, so I is less than 17 and I is less than or equal to 16 is pretty much the same thing. Okay, I'm gonna clear this. Okay, I'll kind of also do this one because it's pretty much the same question as the while loop question, but you're just gonna transfer all the information from the while loop and you're gonna put it into the for loop, right? So I can just show it here. I'll leave all the info here so you can see it, and I can just copy and paste all this stuff. right? So the first step within these parentheses, so you have three things in these parentheses, right? The first thing you have is your initialization, which is your control variable, or the start of your loop, and I could just paste that in here, right? The second thing you have is your condition, which I can also just paste it in here. And then the third part is your incrementation, which is how you're changing the control variable so that the loop will eventually end. And then you could just move this part in here. So if I comment this all out, you can see that it prints the exact same thing as last time. Yeah, prints the same thing as last time. So while loops and for loops kind of can almost always be put to the same use, but in some cases you can't do that. Okay, I'll just skip through this. So there are two ways you can change the flow of a loop, right? So let's say you don't want it to go exactly every multiple. Let's say you want to skip some, right? You would use a break or continue statement, right? So there are two of these statements, and I'll go over the break statement first. So the break statement basically just ends your loop, right? So if the program runs into a break, the loop will end, right? So if we go through this, I equals 0, 0 is less than 5. Since this condition here is false, like we learned in conditionals, it's going to move on. It's not going to carry out this code here. And then 0 will be printed. I will be incremented. So it'll now be I equals 1. Since 1 is less than 5, this condition is true and this loop will occur, right? And this is also false, so it'll go again. And now you reached I equals 2, right? So 2 is less than 5. And since 2 is equal to 2, this condition is true. The program will read this break statement. And once this break statement has been read, the entire loop will end. That's why you only see 0 and 1 printed out here, right? Because once I reached 2, the program read break, and then it broke out of the loop and it stopped the loop. Then we can talk about continue statements. So continue statements are a little bit different from break statements. They kind of end that iteration of the loop, and then it just skips the rest of the stuff, and the loop will still happen though. It just skips the 2. So let's just skip all the way to I equals 2. 2 is equal to 2. The program reads continue, and then it skips out all the stuff after the continue statement, and then it goes back up here to the while loop. Right, that's why you see 0, 1, 3, 4. I think I have to move this incrementation up a little bit just so that this continue statement, because when you have a continue statement here, it just skips everything. That means it's also going to skip this incrementation here. So I think this is wrong. That was my bad. It's going to skip out here and the loop will occur like constantly, which is something you have to fix. That's why you have to be careful when you have a continue statement here, that you want the loop to still be able to increment, or you want the control variable to still be able to increment so that the loop will eventually stop. Okay. I guess we'll just talk about methods now. Yeah, I'll skip all this practice. All of it is on like in the slides in the folder, so you could just go through the slides and see it for yourself. Yeah, Catherine.
Okay, so I will be talking about methods. So let's get right into it. Okay, so what a method is just a block of code that only runs when called. So an example of this would be like a car, right? So what can a car do? It can speed up, it can turn right or left, it can stop, it can brake, all those things. So if we write the instructions to brake in a method, we can call this method by like stepping on the brake. So why this would be beneficial for us is that if we want to do a certain action, like turn right or turn left with the car, in different parts of the code, instead of copy and pasting the code over and over again, we could just call a method, and that would be a lot easier to do, a lot faster. So this is an example of a method. So it prints the sum of 10 and 20. So this is like kind of the structure. We'll go over it more in detail, but basically what's inside of the brackets is what will actually be run when the method is called. So breaking it down a little bit more, the first word is public. So that just means like the method's access level. So for like robotics and things that we'll be doing, we'll usually be making these methods public, so you don't have to worry too much about it. The next one is static. We'll also be using static usually, so you don't also have to like worry about it too much. And we'll talk about it a little bit later. Void is a return type, and add is just like a variable name. It's just the name of the method, so that like we can call it by its name later on. And the stuff inside the brackets will just run when the method is called. Okay, so we'll be talking about public. So public is something called a modifier, and it controls the access level of a method. So usually public methods can be accessed by any other class, and we'll talk about classes later. But basically it's kind of just like our usual definition of what public is. Like everyone can see it, everyone can use it anywhere basically. And private is kind of just like it can only be accessed in its own class where it was created, or basically the access is limited for this method. And there's a few more, but these are the most common that we'll probably run into in robotics the most. Okay, and the return type. So in our before example, I can go back to it. Our return type was void. So what void means is that nothing was returned. So before we only had a print statement, so nothing was actually like returned. And we'll talk about what return really means later on. But if nothing is returned in a method, we call it void. But sometimes when we do want to return something, like in this example, we'll have like a data type, a return type, like int or string or Boolean. Any of those could be a return type. And that would mean that the thing you're returning in this method has to be that data type. Okay, so more on return types. So we can see like, again, add has a return type void. It's only printing something, nothing is being returned. And we just want to differentiate what printing and returning are. So printing is just kind of showing you something on the console, but returning has to be explicit and has to be written into your code. And we'll see that a little bit later, but returning is different from printing because printing is more visual, it's just for the human, but returning actually like gives you back a value that you'll be able to use later on. So the difference is that now the return type of this method is int. So we can see that there's a return keyword here. There's the word return, and that means that this method is going to give you 10 plus 20. It's not going to show it to you on the console, but it's just going to return it to you. Yeah. Okay, so what is an example of a possible value that this method can return? So if you're watching a recording, you can pause the video and try to answer this question. Hope you pause, but I'll give you the answer now. So since the return type here is string, right? So we want to only return a string, and this could mean anything like hello, Iron Maidens, Few Maidens, or the string 30. Anything with quotation marks can be returned here, but nothing else, or else there's going to be like an error. Okay, so now we'll talk about the method name. So a method name is basically the name that will be used to call the method. So it's kind of like you're talking to another human, you call them by their name, right? You're calling them and they'll like respond to you in some way. This is the same thing as like a method. So you'll have to like call a method to be able to use it. So I could give an example here. So here I have the add method, and to be able to call it, I would just write the name of the method and put parentheses and a semicolon, and you will see that this will print out. So once we call this method, the stuff inside the method will run, and in this case, it's the print statement. So that's why 30 is now printed out in the console. So this is basically how you call a method. You just say the method name, parentheses, and we'll talk about stuff that goes inside the parentheses later, and then semicolon. So that is what calling the method means. So it means that you're using it. So we have parentheses here, right? So in this case, we don't have anything inside of them, but what if we wanted to input something into a method, right? So if we want to add two things, maybe we didn't want to add 10 and 20, maybe you want to add like 20 and like 500 or something. You would have to input those numbers for yourself into the method. So these are called parameters here. So you see that now the parentheses have variables, and these are called parameters, and they allow you to pass information into the method. So parameters are formatted in that you have the data type of that parameter, and then the parameter name, and then you can have like multiple parameters. So this is one parameter and this is another parameter, and they are separated by commas. So even if a method has no parameters like we saw here, right, you still need the parentheses. If you don't have them, there's going to be an error. Okay, so creating a method. So this is an example of another method to get an area of like a rectangle or something like that. It calculates the area of a rectangle. It takes the length and the width as parameters. So that means when you call this method, you will need to like give it some value for these parameters, and it will return an integer, which is the area. So I can give you an example of calling a method with a parameter. So for example, I'll just have one parameter here. I'll call it x, and it's an integer. So this would now be my method. So now when I call this method, I will have to put in that parameter, and I could just put in like 500 for an example. And when I run this, it should print out 520, right? Because I am putting this in as a parameter, and now it will be like equal to x. So whatever is x in here would mean like 500, because that's what I inputted into the method, and it will print out 500 plus 20. So that is how parameters work. You can have multiple parameters. They can be like strings or different data types and stuff like that. And this is just one example here. More examples. So in this example, I have an integer named L, and it's equal to 10. And I have a method here. So it's public. There's no static, but usually we will have the static there. Void means that you're not changing anything. Like you're not returning anything, sorry. And the name of this method is change length, and the parameter is called new length, and it's supposed to be an integer. So it takes the length, and it takes the length to give the new length given a parameter. So now L will be equal to new length. So you're kind of like changing this variable based on whatever someone else puts into the parameters, and it returns nothing. So it is void. So just sit with this a little bit, and I will go to the next slide. Okay, now that we have created our method, we want to use it in some way, right? So how do we use this method after it's created? The slide order is a bit weird, but like I said before, we will call this method using the method name and giving the values for the parameters. And where we would put that, I put it in a specific place. And the reason why I didn't put the call to this method like here or something like that is because we have this special method called the main method. So the main method will always look like this. There will be no changes to the main method. So make sure you're very familiar with the heading for this method. Public, static, void, and the name of the method is main. And you don't have to worry too much about this, but it's needed. And what goes inside of the method is your call to your other methods, right? So remember we had the get area method. we want to run this method or call this method inside of the main method, because the main method is a special method that whenever you press like run on like a replit or something that runs your code, your Java code, it will always look for this main method, and it will only run the stuff inside of your main method, which is why it's so important. So because only the main method is run, you have to put anything you want to be run or called inside of that method. So when we call the get area method here, we will print out 20. So note that the main method does not have a return statement, and this will not change because the heading will not change. So we see that there's void here. We're not going to return anything in this main method. We're just going to like print stuff. Okay. I feel like I went way too fast through that, but whoever is watching this recording, be sure to go back and slow me down if I spoke too fast. You can go through these conceptual questions, and I can just explain them since I have time now. What does it mean to call a method? So yes, be sure to like, comment, and subscribe, please. So what does it mean to call a method? So when we're calling a method, it's basically telling the method to run. So like we did here, we made this method here. But if we just make this method and like we didn't call it, so if I commented that call out, like nothing will happen, because making a method, nothing happens when you make the method. You have to like call them. You have to call it so that it does what it's supposed to do inside the brackets. So methods are typically called in the main method, like you saw before, because that's going to be the method that Java runs. And what is a return type? So the return type is a data type that is returned by the method. So it could be void, which is not really a data type, but void just means like you're returning nothing, nothing is being returned. But you can return ints, a boolean, a string, a double, or any other data types that we learned about. You can return any of those. Yeah. And what is the structure of a method header? So you can like test yourself on this. It's really important to know. So the first thing is the modifier, right? So modifier would be like public or private. Static is kind of optional. We usually want to use like static and maybe like a robotics code, but it's not too important for our like purposes. The return type, which is what we went over here. The method name, which is kind of like a variable name. You usually want it to be descriptive in some way. So like you don't want it to name it like A or B or just like letters. You want to like describe what the method is doing. So like before it was like get area, right? So that method name is very descriptive. It tells you that you're getting the area for like a rectangle or something. And then the parameters. So you always need parentheses after the method name, and you will need parameters inside. So remember that parameters are structured in that there's the data type and then the parameter like name that you'll be able to use inside the method. Yeah, and then you need brackets, and whatever goes inside the brackets will be run when the method is called. Okay, so we can do some practice. If you're following along, just like try to pause the video, do it yourself, and then I'll go over it on my Replit. So how could you call the following method? So this method is actually our real turn degrees method in like our robotics code. So you guys, if you like want to understand a little bit, just like, yeah, you can read over our robotics code. But how would you call this method? How would you be able to use this method, right? So I'll give you guys a second. Okay, you can pause this video as long as you like, but I'll just go over it. Okay, so this is one way you can call this method, right? So you would, like we said, you would put this in the main method in like a replit or something. And this method needs a parameter that is going to be a double, and it's supposed to represent like an angle, right? So here we're putting in the parameter 102.3. So is this the double? Yes. So that is checked off. And that is all we need for this method. And always remember that semicolon. So you need the name of the method and the parameters, and make sure that your parameters are the correct type. So in this case, it is. Okay, question 2. Make a method that takes 3 integers as parameters and returns the value of the 3 integers. So this one's actually a bit tricky. So I'll give you guys a second to pause this video. Okay, hope you pause this video. I will go to the answers now. Okay, so we want to make a method that takes 3 integers as parameters, right? Do we have that? Yes. So A, B, C, those are going to be our parameter values. And notice that the name of this method is average because we're taking the average of 3 integers, and the return type is double. So be sure that you're returning a double and not an integer, because the average of 3 integers might not always be an integer. There might be like decimal places somewhere when you're dividing. So double average. So this is going to be the value that it's going to represent the average. So I'm going to be adding the 3 integers. And since adding 3 integers is always an integer, we want to divide by a double value to get a double value back. So if we just divided by 3, that would be called integer division. So even if there is a decimal place in the actual division, that like anything after the decimal place would just get wiped out because we're doing integer division. But since in this case we're doing dividing by 3.0, which is a double value, we will get back a double average. So this was kind of the tricky part that you had to realize, that you don't want to do integer division, you want to do like decimal division. So make sure that you're like changing this into a double instead of just an integer. And you want to return the average. So you want to give back that average. So like later on, maybe somewhere later in the code, you can use this value. Okay, I have time, so let's go over this too. Make sure to pause the video, guys. Okay, so hope you paused the video. So now we want to make a method given 2 integers if one integer is a factor of the other. So return true if it is, and return false if not. So answer is revealed here. Okay, so this is the actual method part, and this is kind of just like calling the method. So we'll go over this part first. So public, static, those two just don't change. And Boolean, right? So we want to return true or false. And true or false are Boolean values. So that's why we want our return type to be a Boolean. We could just name our method factors, and we want to take in 2 integers as parameters. So we have int num1, int num2. So they're integers, and you could just name them whatever you want. Okay, and inside of this method, we have an if statement, a conditional. So what this is saying is, I think there's a typo, but this is supposed to be if num1 is divisible, if num1 divided by num2 gives you like no remainder, meaning like they're a factor of one another, then it should return true. Or if num2 divided by num1 does not have a remainder, then you can also return true. So this thing means or. So the 2 lines kind of mean or, and there's going to be another thing called and, which is just like 2 ampersands. If you guys know what that is, 2 ampersands. So this means and in Java, and these 2 straight lines mean or. So or means like if either one of these are true, then then the whole thing will be true. So if this part is true, if num1 is a factor of num2, then you can return true. Or if num2 is a factor of num1, then you can also return true. And else, meaning like anything else, if there's some remainder at all, then you will have to return false. And you can test this method out by making these two variables and putting them into factors and printing out the value that factors returns. It should print out true if you do this on your own replit, because like 20 divided by 10, the remainder is 0, so it should return true. Okay, so that will be the end of the meeting. So if you have any questions after watching this recording, you can email me at lek@bxscience.edu, or you can email Jillian at chongj@bxscience.edu, or you can use Discord. Yeah. Thanks everyone for watching.